Good morning. My name is Jan Yadoni, and I will be talking about the welding metallurgy of the similar frictions of stir welded joints. Most importantly, because they have some very specific problems that, from a welding metallurgy standpoint, you should be aware of. So let's right away get into this talk by talking about generalities in friction stir welding. Being a non-fusion welding procedure, it was developed back in the 1990s to join aluminum lithium alloys, which were very difficult to be joined by fusion welding. It was taken on to joining different metals with different melting temperatures, steels to aluminum, copper to aluminum, etc. So it is a basic understanding that friction stir welding is good for joining similar materials which melt at different temperatures. People have been trying to weld steel to aluminum for a long time, but obviously, because of the big differences in melting point, aluminum usually vaporizes before steel even melts. Similarly, copper has higher melting point than aluminum. So, needless to say, friction welding has been one of the best techniques to join dissimilar materials in the past. Simply friction, rotational. The friction stir welding has been done on dissimilar materials only after it was developed originally for aluminum lithium alloys. So what happens is that it's not a trivial problem to solve, though, the plastic flow of the material. So they don't melt, but they flow at different temperatures. So at the temperature at which aluminum flows, steel doesn't yet, or it just has very high yield strength. So it's not a trivial problem to join two different materials by friction stir welding, although it appears as it is such. And so what happens is that you end up with mixtures, and this is a typical mixture where the two materials, and you can see here white is aluminum and steel is the dark. This is kind of a solid state, kind of a flow together, locking the two materials together is really what happens. And so in fusion welds, we talked about dilution. When we have two materials, we kind of calculate the approximate average composition between the materials. In friction stir welding, we talk about degree of mixing. So how much we mix these two materials is really going to affect how well dissimilar friction stir welds are being made. Another generality about friction stir welding is that brittle and hard intermetallics can form. Right down here, the theta phase and this eta phase. This happens to be the aluminum steel phase diagram. And you can see the differences. I'm sorry, aluminum copper. Here the copper melts at 1040, 1080 C, like aluminum at 660. So you have this very wide difference in melting points. And where we are operating below the melting point of aluminum, you will end up with, in this region, depending on the degree of mixing, with different types of intermetallics. And as my text shows there, these intermetallics can be so hard and brittle that can even stop the cutting saw as a friction stir weld joint of two soft materials. Here's an example. The average hardness of these intermetallics which form can be 2.5, almost 3 times higher than in the base metal. On the copper side, we can see 200, 220 Vickers as opposed to less than 80 in the base metal. So this is the second generic problem which happens with joining intermetallics, is that brittle, joining dissimilar materials, is that intermetallics can form which are brittle and hard. And it's really, really the main problem with all intermetallics. So I will talk about steel to aluminum friction stir welding, one case study, dual phase 600 with aluminum 6061, carbon steel to stainless steel later on, and copper to aluminum. So this was the introduction. Thank you very much.